Good afternoon, everyone. Thanks for joining today's webinar, OMS Part 2, Hybrid Cloud Management and Security, with Chris Shalda from Cortex Services. My name is Karen Shalda, and I will be moderating today's session. Before we get started, there's a few housekeeping items to address. Today's webinar is being recorded and will be available to you after the session. We encourage you to participate in today's webinar and like to make the session interactive, so feel free to ask questions during the webinar, and you can enter them in the question box. We'll also be holding a more formal Q&A session at the end. So, all right, let's get started. Chris, I'll hand it over to you.
All right, great. Thanks, Karen. So welcome, everybody. Thanks for joining me. This is the part 2 of, it's going to be a 5-part webinar series on Microsoft OMS Operations Management Suite. We're going to be doing 5 parts because it is a lot of technology and a lot of great services that make up the Microsoft Operations Management Suite as a whole. So I think it warrants splitting it out into some multiple sessions so we can go a little bit deeper each time. So this session we're going to be focusing on backup and DR capabilities of OMS. So just a little bit about myself. I am the Microsoft Solutions Architect at Cortex Services. I actually just recently celebrated my 10-year anniversary at Cortex, which is kind of exciting. Just have done a lot with Cortex over the years, from starting kind of consulting in the smaller, medium-sized businesses and moving up into more doing virtualization, System Center, into doing Office 365, a lot with Windows 10 and Config Manager now, and in EMS. I've become the Microsoft Solutions Architect, where I'm helping customers think about kind of holistic technology solutions, kind of end-to-end, putting all the pieces together, making sure that the solutions meet their business needs and requirements. So it's a fun position I have right now. I get to learn about a lot of technologies just like OMS and share that information with a lot of customers. So always happy to talk about any of this technology later on. Always happy to answer questions. So I put my contact information in there. Hit me up by email. I'm also on Twitter fairly often now, and using that more as a primary mode of getting my information, because things are changing so quickly, as well as trying to share out important information to people as well. So you can hit me up on that as well. Please follow me. And so today, what we're going to go over is just in general, why is disaster recovery important to begin with? We'll talk about RTO and RPO, what that means, why it's important, some best practices thinking about that. Then we'll get into the Azure Site Recovery component of OMS, as then the Azure Backup component of OMS, how OMS is licensed, so you can have an idea of maybe some next steps moving forward with that. And then as well, where Cortex specifically can help and has helped customers on their journey to the cloud and with OMS and these particular technologies. You can put your questions, like Karen said, in the question box in the webinar here, and we'll address those at the end. And then I will bring up my contact information again, so if you have a need to reach out, you can do that. So let's get started here. So why DR is important? So disaster recovery. It comes down to businesses, right? And your applications, and what's most important to your business is, typically your applications and your data, and making sure that they are available for, your operations, for your customers, for your users to probably in the end is make money, right? Be profitable. And so when those applications and that data and any of those underlying components aren't available, that causes an outage, that can cost a lot of money to an organization. It can cause problems with reputation. A lot of organizations never recover from a disaster situation just because they haven't done the proper planning and put the right technologies in place to just take care of that situation if it ever should come up. Hopefully it never does. So a couple quotes I have here. One thing is, I thought this was kind of striking, is a great quote by Adam Savage, if you've ever seen Mythbusters, is that failure is always an option. As you know, in IT, failure is bound to happen. It's almost guaranteed. And share with you some, I'd say, infallible truths of cloud computing in general. So a few things. Like software itself, it has bugs. I mean, have you ever encountered software that has had a bug? I'm sure none of you can say that you've never seen a software bug. I mean, it just happens, right? And we have to deal with that proactively, reactively, however you do that. But in the end, you can't avoid it. So that software bug could be something minor. It could be something disastrous where it takes down all of your applications potentially. As well, second thing is hardware will fail. It comes down to hardware. Typically, it's mechanical when it comes to what it is. Think about hard drives, right? A hard drive is just spinning disks. Even solid-state disks can fail. Power supplies will fail. You will have power outages. You will have potentially network outages, and that's just something that you have to assume that's a possibility that will happen, right? The third thing is that humans make mistakes. That's just how it is. Is that you can have somebody that's very skillful, maybe doesn't have the best judgment in the world, not taking into consideration everything that to ensure an application is going to stay up and running always, and something's going to happen, right? And so the human factor is always something you have to consider as well. So that being said, a failure is going to happen, And then another quote here that I think can speak very, very clearly to a lot of people in IT that have been in IT for any length of time is anything that can go wrong will go wrong. I think many IT professionals are very familiar with Murphy's Law here. And so that's another thing that you just have to assume that something will go wrong. And that's okay. You just have to be prepared for the situation of a disaster happening. It's kind of like insurance. You buy insurance not because you hope to use it. You have it that you hope that you'll never have to use it, but you're really glad that it's there when something should occur. And so I like to use an analogy here as well. Think about a car as being kind of your applications, your services that are running, and a car is driving down the road. And think of those, you have kind of in a way high availability. You have multiple tires on that car, right? So, or maybe like clustering. So that you're going down the road, you hit a tack, that you get a flat. Now that slows you down, but your application may be still running. Your car's still running. You can replace that tire, and you can continue moving forward. So that's where having additional pieces, servers, redundancy, networking, storage, all that good stuff is really important still, right? And you can handle those small inconveniences. But what happens if you just get in a complete car crash, right? Or your car just starts on fire? That is something that you can't recover from easily. You have to get another car so that you can continue getting to your destination. So that's kind of like a disaster where you have to say, all right, well, good thing I had another car running over here where I can just switch to very quickly and my business can continue moving forward. So that's where disaster recovery comes into play. So a couple terms here that I want to make sure everybody's familiar with as well as we're talking through this subject is RTO and RPO. So recovery time objective is RTO. That's really the time of where you're targeting between how long it takes from a disaster to occur to when you're back up and running from a business perspective. And that's kind of, you might hear like kind of business continuity, but that's the break between the business continuing. Now on the other side, it's the recovery point objective. So this is how much data can you tolerate losing at the point of a disaster, right? So how far back? Is it 5 minutes back? Is it 10 minutes back? Is it an hour back? Is it a day back? And this isn't just a one-size-fits-all for every server, every service, every application across the organization. You do have to think through your applications, what's more important than others. You might have some mission-critical applications that, man, we can't lose more than 5 minutes for that. Where we have test dev, it's like, well, if we had a backup a week ago, we're okay. And then there's other parts as well. Mission critical, you probably need to get those back up and running right away. Let's say your healthcare organization where you have some applications, your EMR, your electronic medical record system, you need to have that up and running. Otherwise, doctors and clinicians, they can't take care of their patients, and that could be potentially life-threatening at that point in certain situations. So you need to make sure that you're able to get back up and running as quickly as possible. And there's only so much you can do from a high availability standpoint within just a single like data center, right? So that's why you have to consider both of these. And these are business decisions, because you're going to see that if you want to have a very small RPO, a very small RTO, maybe you say, well, I just want to have 0. Well, that's not exactly feasible because that's going to be a lot of money. So there's an inverse relationship here of as the smaller it gets for RPO to RTO, the cost will increase. So you have to understand from a business perspective and per application, of course, what is the best, most cost-effective RTO and RPO for you there too. So you're going to need to get your current RTO and RPOs and compare those, if you're looking at a new solution like we're going to present here today, and to be able to say, okay, if we want to get it to where we are today, what is that? Otherwise, if you have a goal to get even better, how to address that. You're going to have to test your options, estimate your costs, because every business is going to be different. And then you do have to get the business owner agreement on those RPOs and RTOs. It's not necessarily just an IT decision. It has to be the business units that agree that, okay, yeah, my application, all right, if it takes an hour to come back up, I'm okay with that. Or if it takes a day, that's not a problem. But you need to get that agreement. Then when you implement it, you need to be able to measure that ongoing. So those are very important numbers to understand. Another thing too, it's kind of interesting, after the RPO and the RTO, so after that disaster, you've gotten the disaster back up, then you have the PTO, which is you take some time off because you've earned it at that point. Hopefully you never have to go through a disaster at that length, so hopefully that'll never have to happen. But again, it's better to be prepared there. So this is just a graphic here. It kind of gives you an idea of, from that RTO perspective, the recovery time objective, how long it takes to get back up and running, what your options are. Now, backup theoretically could be a disaster recovery option in some scenarios, right? That could just be some application data. That could be, you have dev test, you have some archive servers that are storing, historical data, and you don't have to get that back up right away. So that's might be okay, but usually backup's not going to be a good disaster recovery option across the board. You're going to have other things like in the middle here where I'd say let's go all the way to the right side, high availability. You have applications you need to keep running as much as possible. You have to be able to mitigate from hardware failures, hard disks, and power supplies and other things, servers going down. That's where you do clustering. That's where you do high availability with your hypervisors. You have SANs that have redundancy and storage, that type of thing. And then in the middle is that disaster recovery, where you can't always rely on high availability because that entire site, something could happen to it. Disaster recovery is to help from having in the middle there. It's going to have a little higher RTO, of course, than high availability, but that will help for you not to re-architect for high availability in a new site if everything was to go down. And you just had backups, for example, you had to rebuild everything. Having a disaster recovery solution that's already has everything to as built as it can be, and then be able to be orchestrated to be fully configured is really important. So this kind of just gives you an idea of where those are at, and every one of these has its place and can be used, and most times should be used all together. So let's talk about site recovery. With causes of IT disasters, this is really interesting actually. It's important to understand or establish those causes or downtime that you might have, right? Most people, most organizations associate the need for DR for when a true quote-unquote disaster would strike, like a superstorm, like Superstorm Sandy or Katrina, the earthquakes in San Francisco, a tsunami, whatever it is. But the thing is, in reality, most causes of downtime, are really due to operational failures, power failures, IT hardware failures, network failures, and software failures. It's not even close to as much as it is for those natural disasters to occur. And then you have on the other side too, very interesting, human-caused events. Human error itself happens to affect kind of your business being running constantly and having to have a disaster situation more so than those natural disasters. So this is just very interesting. You might need to kind of rethink what a disaster truly means and what causes it could be from. There's only so much that you can do to prevent all of these from happening. So what comes down to is like, okay, great. I understand that we need to have a disaster recovery solution. There are a lot of causes. We can't mitigate all of them, but there are some challenges there. Some of those challenges starting off is the difficulty of protecting those complex environments and applications around Windows, Linux, VMware, HyperV. Typically you have to have multiple solutions that handles that, and a lot of times you might miss something or leave a system unprotected. It's something we see as a normal occurrence, something that's just not caught, or it's just not part of the solution set in terms of being able to handle the disaster recovery. Also, not all solutions provide that end-tier application-aware replication. So replication can often be a burden that takes longer than expected to handle those multiple tiered applications. Even if you're using something like AWS and Amazon Web Services, customers still are required to maintain that subscription while they're doing something with DR. That is still a cost factor there. It means also having to manage a subscription for the cloud provider and the DR service, which can create some pain during initial setup, performing recovers, and receiving support, as well as paying the bills. And having a solution isn't enough if it can't recover an environment in a sufficient amount of time. But you can overcome these challenges here, where with Microsoft solutions, you can protect any platform, whether it's Windows, Linux, whether it's physical machines or virtual on HyperV and VMware. You can provide application consistent protection for all those applications, so that if a disaster is to occur and you restore everything within an application set, if you have a web server, database server, application server, it's all consistent and is able to be recovered kind of at the same point so that you don't cause issues at that recovery. And then you can provide recovery points at times that can meet the business's needs and free up resources, reduce that CapEx and OpEx costs, and be able to verify that your DR capabilities by testing them without impacting production, which is pretty huge. So this gets into site recovery. So this is called Azure Site Recovery. And this is through the overall OMS suite, so Operations Management Suite. And this is a SaaS-based disaster recovery, so software as a service. This is based in Azure, and it's automated replication and policy-based protection. You can orchestrate the recovery of your workloads with one click. It's seamless integration with other services that are based on Azure. You can do health monitoring of everything, have multi-tier applications, everything being consistent for recovery. And then it's a huge thing. It's very unique, is having no impact DR testing. So these are things that you can use, this technology used to overcome those typical challenges from a disaster recovery situation. One thing that's actually really key here is it's a simplified deployment. It's very quick and easy to set up Azure Site Recovery and to set up the recovery policies on your terms. Since it's a SaaS-based offering, you don't have to have there is, in some situations, I'll have a little asterisk there, some situations you do have to have some on-prem storage or some backup components there to handle some of the replication. It's pretty lightweight in general, and you don't have to have a ton of storage like most other solutions require. And that's typically made for VMware. You do have to have some servers on-prem, and we'll get into that a little bit later on. But in general, it's a pretty low cost of ownership. It is enterprise-grade protection. It gives you flexibility because you can also protect different parts of your data center, different data centers if you want. Critical applications can be set up with policies that are more stringent for those requirements that they have. Maybe they're set to a lower RPO, longer retention, while those lower tier applications, like dev and test, can be a lot more relaxed. And Site Recovery's application, or its replication rather, it uses application consistent snapshots to ensure that application health is there for when you're recovering both single and multi-tier applications. And additionally, the multi-VM consistency is available when all the machines in the protection group are running the same workload. So all machines will be recovered to the same data point, And this is available whether you're replicating VMware VMs or Windows, Linux, or even physical servers. In many solutions available in the market, you'll see that it's very difficult for customers to test their DR plans. And if you're not testing your DR plan regularly, companies may find it really difficult to perform an actual failover, a recovery itself of their workloads. And one of the key advantages of site recovery is it's non-disruptive testing, meaning it will not disrupt the continuous replication of business-critical applications to the secondary site. But at the same time, you can test that the entire recovery solution works to your expectations. If you're not testing your disaster recovery, you should just assume that it won't work, is basically my recommendation there. And my thought is because, and the problem is with the challenges, it can be very costly to go through what they call maybe a DR drill, and you have to shift everything over to a secondary data center. Maybe you are actually running production out of that secondary data center, but that if there are any issues with replicating over, recovering over to that, it can be very impactful to production and cost a lot of money to kind of recover from that, even testing out your disaster recovery. But testing recovery plans more often leads to more successful recovery when the time comes. And by testing, you just know that your DR plan works and you'll have a peace of mind about it. And as a disaster recovery solution is born in Azure, this ASR, or Azure Site Recovery, can leverage the services of other services in Azure. So key is automation, which is another pillar of OMS, which enables customers to automate predefined or custom scripts to run anywhere during post-recovery. You can connect to ExpressRoute, which can remove traditional blockers in networking, like when you're sending massive amounts of data to Azure, for example. Disaster recovery is a perfect example is moving terabytes of data when pushing the initial data to Azure, or when performing a failback post-disaster. It's good to have those other services in place like ExpressRoute. So here's a graphic here just to give you an idea of all these capabilities, right? You can do a site to Azure, you can do site to site recovery, you can have VMware and Hyper-V and physical servers in your same environment and be able to recover from a disaster for all of those. And site to site, you can go physical VMware to VMware, VMM to VMM. So there's a lot that you can do there. Linux, Windows, everything. We're going to get a little bit deeper into a couple of the scenarios here from disaster recovery standpoint. So a lot of organizations, they have VMware, right? So you can use the VMware SitetoSite to have basically 2 data centers, right, where you essentially are managing that replication across both sites, but at the same time are able to do things like the orchestrations after the fact to get the servers turned on in the right order, run a script to change DNS in the middle of the process, wait for something else to occur before you turn on this server, have any other sort of scripted steps, and the ability to also at the same time to potentially test those DR scenarios as well. We have VMware SitetoAzure, which I think is truly, this is what lowers that cost, because you don't have to maintain a secondary data center yourself that you have to pay for. You have to pay for, if it's a colo, you're paying money for it's really the property, right, or the area that you're putting your servers in, the servers themselves. You're paying for the internet and the power and the cooling, all of that, usually just to have it sit around and do nothing, right? And so when you're doing something like this, we're going VMware to Azure or Hyper-V to Azure, physical to Azure, what's key to understand is that you don't pay for those servers just sitting out in Azure and running. You just pay for the storage that they take up, and then there's a per node, as they call it, per server cost to just have this DR service running. So it's very cost effective, especially with Azure. That's where your total cost of ownership is extremely low. So as you see here, it just replicates essentially the VMDK files from VMware to Azure. It does some conversions in the middle where they essentially get converted to VHD files in Azure, sitting there waiting in case there's a disaster. And when you do recover, it rehydrates those, basically the VHD file in Azure, and runs orchestrations to build out the VMs and to do that all in the order that you need to have it done. And at the other side of this too, you can also fail back to VMware. Let's say it is a transient issue where just your power was out, network's out, whatever, on-prem. You need to get things back up and running in Azure. You got everything still, got everything back up and running on-prem. Well, you can fail back, and the delta is everything that's changed since you did the initial failover. Come back to on-prem. You have that also orchestrated so you can go back to doing businesses as usual. Same kind of concept with HyperV SitetoSite. You can use SCVMM to coordinate some of this as well. Don't have to, but same idea as kind of the VMware side. SitetoSite, SitetoSite does require SCVMM, and HyperV SitetoAzure does not, but you can use that as well. So some things just to think about planning-wise is that you have to plan your bandwidth, right? So you are going to be replicating information from on-prem into Azure in most situations, or site-to-site even. You have to understand that how much bandwidth you need for that. There is an initial upload, and then there's ongoing usage. The initial upload will be the largest bandwidth used, but this isn't typically time sensitive, and it can be a phased approach. So you can say, all right, we have 1,000 servers, but we're going to start with these 100 and get those replicated up, and then we're going to go to the next set, and the next set, the next set. And you can schedule this and throttle it so that it's only doing the major applications for the initial kind of seeding overnight, let's say, where you have less production usage and you're not impacting production as much. We've even seen customers maybe increase their bandwidth with their ISP for a short period of time while they're getting everything initially seeded, and then they'll just come back down to where they were before, potentially, if the ongoing usage is within that range of what they had available. And that's just you might need to increase a little bit for that ongoing cost, right? The ongoing bandwidth that's needed, but that's something that you just have to, you have to calculate that. And then from a network perspective, in order to do a failback, you do have to have a hybrid networking setup. So that could be site-to-site VPN. It could be also ExpressRoute. That just has to be understood, how much bandwidth, what are the limitations around that. Most of the time, you do want to do a failback. So that's where having this network is important. This hybrid networking, you do not have, it's not required. If you want to just do on-site to Azure and you want to leave everything there, you could definitely do that and not require that VPN connection or ExpressRoute. Then you have to do some storage capacity planning of how much data is going to be required depending on your RPOs, how many protection points you need for your servers, what the change rate is, whatever else on in Azure Site Recovery. So this is storage. You just have to, that is an ongoing cost depending on what you need there. So there's a great calculator, this Excel spreadsheet that Microsoft provides that's a capacity planner, so you can get an understanding of how much that you're going to need, both from the networking perspective as well as storage perspective too. So you can do some planning ahead of time. In preparation, in order to make sure that you're going to be successful, you do have to make sure that your authentication tools are syncing. Once you move everything, if there's a disaster, there has to be some sort of authentication to start the first servers up, most likely. So a lot of times you'll need to already have a domain controller running in Azure at the very least, if not using something like the Azure Active Directory domain services through Azure. It's like kind of a platform as a service offering there to lower the costs. Those are things you have to think about there. You have to know your settings. What are the settings on your servers today? How do you kind of get your servers that are being replicated to those settings? If there's firewall rules, other types of things in order to kind of rehydrate, turn on those servers and make sure that they're working once you have a DR scenario. And that's type of things you need to have completely scripted out and orchestrated and that's why you need to be testing too. Make sure that test will run through the orchestrations and everything will come back up as expected. At that point too, you need to make sure that everything that you're doing on your servers going forward, you're not doing one-offs. You're not just adding a firewall rule, be like, okay, well the scripts got me to a certain point, but then oh yeah, that's right, I have to put this firewall rule in to make sure that it can actually communicate with the SQL server, let's say. Well, if you don't put that in your scripts, you don't put that in your orchestration, then you're going to have that same thing, that issue that's going to essentially break those applications when you're recovering from a DR scenario. So there might be some change of process here that you have to go through as well to make sure that you're maintaining those orchestrations so you can have a seamless DR scenario. configure your network properly. This is IP addressing. You have to determine, are you going to be doing, you can keep the same IP addresses on the servers that you're replicating. You can also have it be a separate IP address scheme, but you have to make sure that everything's set up properly from a routing standpoint and server standpoint with scripting, and your applications understand if there's a new IP address, that type of thing. So a couple other things you have to do: create your connections properly. That's with your networking, and DNS routing, right? So if you're going to be if your server's going to be running out of a different data center, it's probably a different public IP address, so your DNS has to be set up properly. There's tools and services to do that, Azure Traffic Manager, or you just run a script and you have to understand what your TTL is for your DNS record, how long is it going to take to change that. So just a couple things to keep in mind. But beyond just the typical DR perspectives of what you see in DR solutions, the seamless migration is something that's very interesting you can do no matter what the source is. So if you do want to get to Azure, and that's your end goal, and not just to do DR, but you want to start moving workloads to Azure, you can actually use this Azure Site Recovery service to essentially replicate to Azure. You do a quote-unquote failover, but you never fail back. You just leave it there. And so that's something you definitely do. You can test that, right? Again, it's like the failover test. You can test that in an isolated mode to make sure that everything's working before you do an official failover to Azure, but it's a very cost-effective way of doing this. And one little tip here is that Azure Site Recovery, it's free for the first 31 days, so per server. So if you wanted to migrate your servers and you did that within 31 days and you turned off that this Azure Site Recovery service, it's actually free to migrate that particular server to Azure. So just a little tip there. And this is built for testing. I can't stress this enough. The capability of flipping a switch and doing a planned failover or a test failover to say, all right, we're actually going to isolate the network within Azure and do that failover. We can run everything. Does everything connected to main controller? Does it come up in the right order? Are my applications working and whatnot? And test that everything from a scripting and orchestration standpoint is set up properly. That is huge, and it saves a ton of time. It reduces a ton of risk. So that is definitely very unique. And then when you're done with that test, essentially the VMs are stood up for you in Azure, but when you're done, it just tears down the VMs. And the only thing you're paying for at that point is the storage cost and the per server cost for Azure Site Recovery. You do pay for those VMs while they're running, but typically that'll be for a short period of time while you're either testing or you're going through a DR situation where you have to run them in Azure, and then you're going to fail back, and then you just kind of you destroy those VMs. So you might say, well, why Microsoft? Why should I go with Microsoft as opposed to somebody else's solution here? Well, it is a native first-party solution that's trusted from a trusted cloud provider. It is a single provider that can handle all of the different server types, whether it's virtual, physical, VMware, HyperV, Linux, or Windows. It is one vendor to pay for all of that. And for those mixed environments, that's huge. And you can have this in a hybrid design where you can actually, one scenario I didn't have in here was not only can you do it from on-prem to Azure, you can go from Azure to Azure. So if you already have VMs running in Azure in IaaS or infrastructure as a service, well, what happens if something was to happen there with your applications, one reason or another? You can have them replicated to another region within Azure. Or another paired data centers. There's at least 2 Azure data centers in every major region that are at least 400 miles away from each other in a different climate zone, so that you can still have them within the same region if you have data sovereignty issues or just want to keep the servers nearby or in the same country or area. You can then have it go from Azure to Azure from site recoveries. That's a little bit newer development, but that just adds to the value, I think, of the overall solution, especially as customers start seeing them move to the cloud more for their primary workloads. And really, sky's the limit, right? So it's unlimited scale of how much you can do with this and how many servers that you can protect. So now I want to talk a little bit about backup here. You said they're not the same. Backup and site recovery, they're not the same thing, but they're complementary. And they both have a place, and I think they both should be used in tandem. And what's really nice is that Microsoft has, as part of the same solution, they work side by side with each other, and again, single vendor, right? Easier to keep everything together, monitoring and health and costs, everything is very cost effective to look at the same vendor there. In this case being Microsoft. So I mean, IT organizations, are in a situation of this perfect storm for data protection. You're hit from all sides. On one hand, you have proliferation of the SaaS technologies, and then you have adoption of the cloud, where really traditional data protection paradigms they truly don't apply anymore. They're just not cost effective or are going to add the value that you need, that is expected, really. And on the other hand, in data centers controlled by IT, there's this change of data center modernization, including virtualization, other solution scenarios. It's forcing IT to reconsider old paradigms. You can't rely on unreliable and rigid legacy methods such as tape backup anymore. It just does not provide the agility that modern app admins demand. So these challenges mean that IT organizations typically adopt multiple data protection technologies. In a recent survey, it said that over 60% of organizations envisions that they'll have at least 4 data protection solutions in their environment by 2017 now. These point solutions come with multiple management solutions, adding to the complexity overall, and in the end, it's cost. So now you have to also deal with this explosion of in-backup data, which translates to budget challenges. I mean, there's multiple copies of backup data for each piece of production data, hence when production data grows exponentially, backup data necessarily grows even faster than that. So it becomes very costly to retain more data and a lot of complexity to ensure that that data is being protected as well. The final aspect is really of complexity is driven by remote and branch offices in enterprises. There's a pressure to adopt direct cloud paradigms, but adoption is hindered by the heterogeneous nature of the workloads and the approach of using cloud as a storage target or another owned data center usually causes more problems than it solves, having to have a colo or a second data center stood up just for the data protection. I mean, if any of those challenges hit too close to home, don't worry about it. We actually have a solution for you here. So OMS, here, backup is built from the ground up to be a cloud-first enterprise backup solution. And it's designed to be simple, provide you with 80% of the functionality you're used to at 20% of the cost and complexity of your current solution. It's also designed to be reliable and durable, and it's backed by enterprise-grade SLAs from Azure. So again, it's heterogeneous environment. All your managed servers and everything stored in Azure. It's on-prem or in Azure. You can get item-level restore for most enterprise applications, and you have the enterprise-grade SLAs. Very cost-effective because for long-term retention, you can do, I believe now, up to 99 years of retention for your data backups, and it's protected per instance. It's per instance-based billing, so it's very cost-effective there too. And the OMS-based management instance cost grows only linearly with apps and VMs. It's pay-as-you-go for nonlinear growth of backend data cost. Secure and scalable as well, so you get the peace of mind with that enterprise-grade security and encryption. That data never leaves your premises unencrypted, and you can make use of that infinite scale of Azure to back up all of your assets and eliminate your off-site backups required. So it really achieves this by taking a fresh look at the data protection domain and wondering, what would a cloud-first data protection for modern enterprise look like? So this is what it addresses all the major challenges facing IT organizations to offer a consistent management experience, irrespective of the backup scenario. It delivers backup and storage as a service directly from Azure. So it lets you leverage your limitless scale of Azure to deal with the explosion of your backup data. It offers solutions for heterogeneous data protection scenarios across modern enterprise, just irrespective of where the app or the data resides. So you can replace tapes with Azure at a much lower TCO and better manageability and agility. You can make sure the data in your branch and remote offices are backed up from file and folder backups directly to the cloud with what they call MARS agent, so the Microsoft Azure Recovery Service agent. You have operational backup on disk for remote apps and virtual machines backed by unlimited tertiary copy of Azure with Azure Backup Server. And then from IaaS VMs, you can protect born in the cloud applications as well. You're then able to have long-term retention to Azure for all the scenarios, short-term retention to disk for fast operational recovery supported by Azure Backup Server and DPM on-prem, and then long-term retention to tape is supported by DPM if it's required. But at the heart of OMS Backup, it's just radically cloud-first architecture. Backup and storage are delivered as a first-party as a service offering. But you may be wondering, so why should we care whether backup is a service? How is that different from other vendors offering called cloud backups? Well, you can look at most cloud backup vendors offering more or less of a duct tape solution. I mean, for example, the backup vendor, and the cloud vendor they have to work together, right? There's two separate vendors there. So there's two variations of cloud backup. There's the first one, which is cloud as a storage target, and the second is cloud as another data center with IaaS services. So both of those approaches are very limiting. With cloud as a storage target, there are several issues. It treats cloud as another dumb storage target, which means restoring anything will usually require you to bring down the whole image, which takes a lot of time, it's costly, and it can impact network, of course. It does nothing to prevent infrastructure and multi-point management sprawl on premises. So typically it will require more management servers and other sorts of hardware required on-prem. And it perpetuates licensing issues and increases TCO of the solution, so it can be a lot more expensive. And also, it's usually a complex multi-vendor solution, so it's very difficult to manage, maintain, support. Now, with cloud as another data center, that's not a superior alternative either. It means that customers have to make use of expensive cloud IaaS to host traditional backup software. It's limited by any limitations imposed on the cloud IaaS itself, for instance, maximum of 32 terabytes per VM. It's usually a multi-vendor solution, again, increasing the complexity of the solution and cost. So in contrast, Microsoft looks at this really different and radically simplified approach where customers work directly with Microsoft, who delivers the whole solution as a service. So as a first-class SaaS offering, customers need not to maintain any infrastructure, resulting in minimal maintenance for the backup solution. It allows for intelligence on the backup data, such as when item level restores from the cloud, and enables customers to achieve really true cloud scale. So let's look at some of these remarkable benefits that we see some of our customers experiencing by adopting OMS Backup. So as its first-class SaaS offering, those customers don't need to maintain any infrastructure, resulting in that minimal maintenance for the backup solution. That storage and backup, since they're delivered directly as a service backed by an enterprise-grade SLA, that is also a very big value. There's no compute, storage, or networking maintenance required by the customer. It's also a greatly simplified licensing scheme as well to reduce costs and be able to plan appropriately for increasing the protection of new workloads. And for instance, you can have intelligent restores and restore an item from SharePoint that you back up via a DPM server directly from Azure using any other DPM server. You can bring the agility of cloud computing to the world of data protection. And secondly, OMS Backup, it's designed to be cost-effective for both long-term retention and operational recovery. So for long-term retention, you do pay-as-you-go for the commodity blob storage, and you pay only for front-end costs with OMS licensing. And finally, as a service offering, you achieve true cloud scale, which will consistently offer 99+ year retention on the cloud based on a rich GFS scheme. So that's a grandfather, father-son scheme. Now, customers also have access to another benefit that's unique to OMS. It's backup owing it to its cloud-first architecture. So simplified management here. So, for example, it'll allow you to enable protection in 3 easy steps here. So you can choose a scenario where you answer a few simple questions like, where's the application or data? Is it in your data centers, in a remote office, or in the cloud? Where do you want the protection? Is it locally or on the cloud? What type of media do you wish to use, disk or tape? You choose the retention. So You can enforce a consistent protection across enterprise scenarios using a simple but powerful policy construct. So the policy captures intention of when backups occur and how long that they are retained. And then the third step is you enable it. So what's more is that the management entity also serves as a logical endpoint for all backups across the entire enterprise, remote and branch offices, and the cloud. So all of those areas, all the places that your data is today in production, you have a single management entity that handles all of that. It's designed to work together with other OMS services like OMS Site Recovery, like we mentioned, to enable comprehensive data protection. And all the enabling technologies within OMS Backup, be it the DPM or ABS or MARS, have the intuitive and simple management interfaces. Now, an increasing number of applications are moving to the cloud with IaaS as a fabric, but simply because an app runs in the cloud fabric doesn't mean that there's no protection required. I mean, actually, just the opposite is true. While cloud vendors usually provide SLAs against errors in the cloud fabric itself, they don't make any provisions against data corruption. And these corruptions could be either malicious or through a simple human error, such as a fat finger delete. The key takeaway here is that redundancy is not backup. It's not the same, whether that's on-prem or in the cloud. And irrespective of resiliency of the storage layer on premises, for instance, backup is still an imperative. The same holds true for your critical cloud assets. So the IaaS VM backup, it uses controls and mechanisms that IT departments are already familiar with things like grandfather, father, son retention scheme that allows up to 99-year retention schedules. That in the cloud first architecture backups, they occur at the cloud fabric layer and not at the application or VM layer. What that does is that translates to near zero impact on your production workloads running on Azure. And it also makes use of technologies such as VSS, so volume shadow services, to deliver application-consistent backups of all your Windows virtual machines, and now even Linux is starting to be part of that as well. And also, so it can fail back and deliver crash-consistent backups as well on VMs, or VMs that are turned off, for example. So moving away from the cloud, let's look at some of the challenges in remote and branch offices or enterprises. A lot of times there's a lot of bandwidth constraints with remote offices and branch offices. And with OMS Backup, you can back up directly to the cloud. And this has a set of direct-to-cloud backup capabilities for Windows servers and clients, which not only reduces management headaches, but virtually eliminates backup hardware costs at those remote office and branch office locations. So you can also have quick operational recovery of those. And those files and folders can be recovered directly from the cloud. So an enterprise backup here is, you can replace your cloud, or replace unreliable tapes. I mean, literally, tapes are no good nowadays that we have cloud backups. But you can use it if you want to. The Data Protection Manager capabilities will allow you to do tapes if you need them. But DPM has a wide application support as well. It's also built for hyperscale backup of private clouds based on HyperV, and also now has VMware support. It boasts a wide range of enterprise-grade features such as recovery from any server from the cloud, deduplication with the right storage setup, etc. And existing customers that are already using DPM can leverage the backup as a service offering of OMS Backup to eliminate unreliable tapes and increase the agility of their enterprise backups by using Azure as their offsite target. So that can significantly reduce TCO, but also make recovery much more reliable and streamlined. So this is just kind of a picture here of all the pieces that are kind of in place within the backup solution. So you see you have hybrid backups on the left side, which is going to be your on-prem to Azure, and that's going to cover Hyper-V, SQL Exchange, SharePoint, VMware, physical, and that's going to be those workloads, item level recovery within applications there. and that's going to be done through typically an Azure backup server if you want to have that entire server image backed up, or System Center Data Protection Manager. Then you have the Mars agent. So this is the Microsoft Azure Recovery Service agent. This gets installed on the servers themselves and will help you with file and folder backups. If that's all that you need, then this is a very lightweight way of doing that, and especially good for remote offices, branch offices. On the right side there is the cloud backup, right? So if you have first that backup extension, if you in IaaS you have a VM, you can actually the Azure Fabric layer will back up that VM without having to impact the performance of the VM, and that's something that's just part of the template when you deploy the VM itself. So very lightweight and very easy to install and configure. As well as SQLAzure, Azure Blobs and Files, that's more of a PaaS, a platform as a service type of services on Azure. Those can be backed up as well with PaaS extensions. And then I believe it's something that's coming soon, and it might even be previewed right now, is for Microsoft Office 365. We'll be seeing some extension from a SaaS perspective to be able to back up directly in using Azure Backup of those SaaS services. So this gives you an idea there. The underlying storage, you have options between local redundant storage, geo-redundant storage, and archive storage is coming as well. So just to wrap up here, this is, we talked about in the first session all the components of OMS, so I'd recommend if you weren't able to join that session to take a look at that. But Operations Management Suite can handle a number of key scenarios. We touched on a couple of those today here, those last two, the backup and site recovery there, but a lot more, and we'll, in further sessions, dive deeper into those. And very tight coupling with System Center, it's a better together scenario as well. To give you an idea from a licensing perspective, how you would license this, a lot has changed since October. I talked in more detail in the first session, so I'm just going to briefly go through this. But as you can see here, you can do pay-as-you-go, and the two on the bottom, backup and site recovery, are the ones that we've mentioned today and went into depth. So backup typically is $10 per node retail here, site recovery $25 per node, and that's pay-as-you-go. So you can go month to month. You can use your monetary commit through Azure, through your EA for that. Now, if you're considering backup and site recovery specifically, you would get, with both of those, you would be licensed for the full DPM, so Data Protection Manager for System Center, and Virtual Machine Manager if you were to purchase that on an annual commitment. You'll see with the other ones there are some other System Center components that you can be licensed for on that server per node, meaning the node meaning a physical server or a virtual machine, whether on-prem or in Azure. Now, what's really cost effective here is with these new packages, OMS E1 and E2, where especially E2 is a great value because now that is an annual commitment, but it's only $35 per node in a retail. And from a retail perspective, you might be less on your EA. And that's the cost if you look and calculate, wow, if you just bought backup and site recovery by themselves, that's $35 per node. Or if you went with OMS E2, you get both of those and the rest of OMS and all of System Center from it's a management license perspective for the System Center components. So that server, that VM, whatever, would be completely covered for all System Center components, as well as backup and site recovery, as well as all those other components of OMS. So great value there. That's a great offering that's very recent and not truly known already. If you already have System Center, there are some just step-up costs. So it isn't going to be the full cost of that E1 or E2 package. It is just an incremental cost. And then when you renew at that point, then it would be less money per month because you're going to combine those together. And so, and one last thing with that is that there are some additional costs you have to think about with Azure Backup and Site Recovery. You do have to pay for the underlying storage consumption beyond a certain amount per protected instance. You do have to do a little bit of calculations there to make sure that you're planning properly for that. But that also kind of leads into how CoreTech can help with this. We've done a lot of proof of concepts, plannings, pilots, and we can also help with deployments too. Proof of concepts are a great way to just start out and say, okay, let's just compare this to what we have today. and where that can work. And honestly, there are a lot of options right now depending on your organization, how large you are, and everything. Microsoft typically has a lot of funding options that are available that can typically at least fund some proof of concept, even potentially some planning, sometimes even some deployment. So that's something that actually I am very on top of from a core tech perspective, and I'm helping all my customers take advantage of that funding. And it's been really helpful to get them moving forward with these technologies. Another thing I'd be remiss to not mention is Cloud Foundations. We've had a lot of success with this. Now, Cloud Foundations is a solution offering that core tech has developed because a lot of organizations want to get to the cloud. We've seen organizations just dive in head first without maybe planning properly, understanding the changes to maybe their organization, their processes, setting the right foundations so that they can build up on that at scale without having to go back and rework something that they didn't think about to begin with. So it's been extremely successful. Customers have been very happy with this. It really comes with, we help you evaluate, plan, and execute a comprehensive cloud migration strategy through assessment, understand the foundations for migration to the cloud of identity, network, and subscription, and just in general help you to future-proof your investments in the cloud. So that's all I have. Kind of running a little late here, but if you have any questions here, if you go ahead and I'm going to take a look in the chat window here, and it looks like we have a couple here. So one of them is, okay, so how long would it take to do a proof of concept for both Azure Backup and ASR? Okay, good question. So honestly, because it's a SaaS offering here, depending on the complexity that you want to get into, for the most part, we've done these, and it's a week or less to do both Azure Site Recovery and Azure Backup to get to the point of understanding those technologies, the capabilities, possibly the limitations, and helping you compare to what you have today and put some rough cost estimates around that of what that would be cost-wise to move forward with those solutions. So great question. Another question here is, do you need to already be using Azure to start using Azure Backup and Azure Site Recovery? So you don't have to already be using Azure to use this. In fact, what's interesting is we see that a lot of organizations, their first step into the cloud is backup and disaster recovery because it's extremely cost effective when compared to other solutions on-prem in another data center, and especially with Microsoft Azure just because of the way that they've structured the costs and there's so many, it's so feature rich now. So you don't already have to be using Azure. You need to set up an Azure subscription in order to take advantage of it, but that's where Cloud Foundations really comes into play, where we would help those customers understand where you really want to go. Let's set up the foundations for your cloud. If it's just backup and disaster recovery today, great. We can focus on that and help you understand where you want to go tomorrow. And even if you have started that journey to go to the cloud, and you've already started going down that path, but maybe you haven't, feel like you've make some missteps, you've quote unquote learned a few things, but don't know how to kind of reset, reset like where you're at, and make sure that you take that the direction you go from now on is going to be the best way. Again, Cloud Foundations is another great option there, really to help you at any point of your cloud journey to make sure that you're being most efficient and you're taking advantage of everything in the cloud, from automation to orchestration, and you're definitely going to be lowering your TCO. So I think that's all the questions we have. Here's my contact information again. Feel free to check us out on our website. Feel free to email me, hit me up on Twitter, LinkedIn. Be glad to talk about any of this technology with you and strategy-wise. Always willing to make myself available for that. And just encourage you to join us for the rest of the series. We're going to be talking about those other three major pillars of OMS, and that's going to be log analytics, security and compliance, and IT automation as well. So hope to see you then. Thanks for joining, and I hope you have